Okay, next review of simplifying radicals. Okay. Okay, 250 times x to the 7th times y to the 9th. Okay. Okay, it's a multiplication problem. You're multiplying, dividing radicals. Okay. Okay, multiplying, dividing, you're going the 6-line setup. Adding, subtracting is on the other side. Okay, so it's obviously nothing but multiplication with dealing with radicals. Okay, first thing, if you got a radical, this is a radical. If you see that, you want to rewrite the radical as a rational exponent if you have to simplify. So put equals, make one parenthesis. Since it's a cubed root, it's a 1/3 power, and you copy the inside. So 250 times x to the 7th times y to the 9th. So you got 250 times x times y. Okay, so 250 with 1 times 1/3 is 1/3. 7 times 1/3 is 2 and 1/3. 9 times 1/3 is 3. None of those are negative. You don't need to move them. Now put your whole exponents first, okay? 3 and 2. X to the 2 times y to the 3. Then put your exponents 250 to the 1/3 times x to the 1/3. Okay, take a look at those fractions, further inspect them, see if you can get rid of them right now, as if those are perfect cubes, because those mean the 3 on the bottom indicates it's a cube root. Well, 250 is not, neither's x, okay? So they stay for now. They're not on bottom, so get that out. Now, those fractions you still got on top, they need to be rewritten in a radical. So that's not a fraction, you just write it. That ain't a fraction, you just write it. Now when you come to the fractions, they're both 3's, so you make a cubed root. Inside you put 250. 250 to the first, that's 250. And then x to the first is x. Now you want to simplify your outsides if you can and your radical term, okay? Well, x second is what it is, so is y to the 3rd. Okay, cubed root, put your x inside. You need to try to simplify the cubed root of 250, okay? So I need to divide into that. You'd start at 216, that's a decimal. But then if I go divide by 125, it's not. So 125 and 2. Okay, the cube root of 125 is 5. So you put a factor of 5 in the front, outside, put the factor of 2 inside, done. Number 2 is almost the exact same problem, okay? Again, nothing but multiplication. I want that radical out, okay? 1/4. And then we have 16 times x to the 12th times y to the 3rd. The reason you know you need 6 lines because you got that rational exponent with that 1/4. It was all good with 3 when they were whole exponents all the way through the expression, but now that they're fractions, we need to look at this. So you got 16 times x times y. 1 times 1/4 is 1/4. 12 times 1/4 is 3. 3 times 1/4 is 3/4. None of them are negative, okay? Put your full first, followed by your fraction. 16 to the 1/4 times y to the 3/4. Okay, are these perfect fourths? 16 is, it's 2. So this is now 2. That 1 is still there. It's a first power on the 2. Y is not, variables are not perfect anything, okay? So we still have a fraction. It's not on bottom, though. It is on top, so we need to use this. Okay, x to the 3rd is x. 2 to the 1st is just 2. Not in a root, though. There's no fraction. Then I make a 4th root of y to the 3rd. Okay. All right, technically the 2 is supposed to come before the x. If you don't do it that way, I don't really care. Then the 4th root of y to the 3rd. Okay, you can't simplify a y to the 3rd. Okay, number 3. Nothing but multiplication, okay? I don't like those radicals there. They're both 3s, so we just make one parentheses to the 1/3, and we have the go-ahead to multiply the insides. 9 times 24 is 216. Y second times y would be y third. Now you're ready to roll. 216 times y. Okay, 1. 1 times 1/3 is 1/3. 3 times 1/3 is 1. They're not negatives. You got your full exponent, y to the first. If you want to just write y right now, you can. Then the fraction exponent, 216 to the 1/3. Check your cubed roots and see if 216 is there. See? Cubed root of 216 is 6. So this is now 6. That 1 is now a power on the 6. Do you have any fractions? Well, definitely not on bottom. Do you have any on top? No, it's a 1 and a 1 out. So that's 6 y. 6 times y or 6y. Okay, number 4. Okay, square root times a cubed root. Well, it's all multiplication. We can still go with that, but the little hint off to the side indicates, gee, I probably need 2 parentheses, okay? 1 for the 1/2, 1 for the 1/3, so you can't multiply the insides yet, okay? So I got a factor of 3. A second factor of 3 means I add to the first one. So 1 times 1/2 is 1/2. 1 times 1/3 is 1/3, okay? 1/2 times 1/3 is plus 1/3. I think it's 5/6. It is. It ain't negative, okay? So, bring it over. I have 6th roots on the back of this, okay? Unfortunately, 3 is not a perfect 6th root, so we will not be getting rid of that just on the spot, okay? It's not on bottom. On top, now you make a radical of a 6, and you need to find what 3 to the 5th power is. 3 caret 5, 243. Okay, can any part of that be simplified? Well, let's check. I mean, the 6 roots are right there. I think it's either 64 or we ain't doing it. We don't do 1. Don't do 1. You can, but it's kind of pointless. No, that's staying the same. It'd be pointless to do a 1. Okay. Number 5, a division problem, same thing. It's a 2x7x2 dividing. I gave you another hint because you need a 1/2 and a 1/3 for your roots. X to the 7th, x to the 2. So I put x over x. 7 times 1/2 is 3.5. 2 times 1/3 is 2/3. Ditch the bottom and minus it from the top. I think that's 2 and 5/6, so I'm going to double check. Yep. 2 and 5/6. Okay, not negative. Now, what you have a whole exponent of 2 and another exponent of a 5/6. Okay, just like that. Well, you ain't getting rid of the bottom with x. It's not on bottom, so now what you need to do is make that into a radical. The x second just drops down. So it's a radical 6, and inside you got x to the power of 5. Now there's nothing you can really simplify now, okay? She's done. Okay, 625 to the power of negative 3/4. Now, oh, it's a multiplication division. It goes in that category, okay, which is our 6 lines. But, do you see a radical? Do you see one of them things? Because I sure don't. We're ready to roll. We don't rewrite it. If there's no radical, it's already in a parentheses with a rational exponent. 625 to the negative 3/4. You need to move that to the bottom. Positive 3/4, okay? Okay, it's your fraction. See if you can turn that into a full exponent. Look at your 4 list. You can. 625 0, it's 5. So you get rid of that and you put 5. Now it's 5 to the 3 power. Okay? It ain't a fraction anymore. Okay? I don't have any fractions on the bottom. I don't have any fractions on top. All I got to do is find what the heck 5 to the 3rd is. 5 caret 3. 5 times 5 times 5. It's 125, whatever. Okay, number 7, x to the 1/3 times x to the 1/5. Another multiplication, absolutely. But I don't have a radical. It's already in rational exponent form. So you got x times an x means I add the powers. 1/3 plus 1/5. I think that's 8/15. I could be wrong. Nope, I'm right, as usual. Not negative, get it out of there. I don't think you can get rid of that. It's not on bottom, okay? Just on top, okay? So, make that into a radical. Yeah, it's a 15th root, x to the 8th. Now you're like, Herbson, you don't have a 15th root. I don't need one. I can't. No, I can't simplify a variable. That's your answer. Number 8, okay? Looks like it's all multiplication and division. There's not an adding or subtracting. That's a 3/4 too, by the way. So we're not going to make a radical. So you got 16 times x times y. There's no radical. It's already in the form I want it. There's a parentheses. There's a power. 81 times x times y. So 16, 1 times 3/4 is 3/4. 15 times 3/4 is 11 1/4. 8 times 3/4 is 6. Now down the bottom you got 81 to the 1st. 1 times 3/4 is 3/4. All these exponents need to be multiplied. 2 times 3/4, okay, it's going to be 1 1/2. And then 16 times 3/4 is going to make 12, okay? Now, you need to get rid of the x on the bottom and minus 1 1/2. You can't leave 2 x's. So 11 1/4 minus 1 1/2. 9 3/4. So I got 9 whole and 3/4. 9 3/4. Get rid of your y6, minus it, and that one's a whole. So we got a 3/4, a 9, a 3/4. Remember, those are 2 separate ones, a 3/4 and a 6. So the 9 and the 6, none of them are negative. X9, Y6, okay? Then you write all your fractions. You got the 3/4 with the 16 on top, and you got the 3/4 with the X on top. And on the bottom, you got the 3/4 with the 81. This is why it is so important that you check your 4th roots. We know X isn't, but it's 16 and 81. 16 is, it's 2. So this will be 2 to the power of 3. This 81, 81's a perfect 4th root, it's 3. This will be 3 to the power of 3, okay? Okay, so now here are my exponents. 9, 3, 3/4 still on that one. 6 and 3. Do you have any fractions on bottom? You don't. You have a 6 and a 3. Those are not fractions. Now you still have a fraction on top, so we need to come here. But while I'm doing that, x to the 9th. Find what 2 to the 3rd is. It's 8. Okay, or you can, at some point, that's got to be made 8. Then a 4th root. And then x to the 3rd. Now on bottom, y to the 6th, okay? And 3 to the 3rd is 27, okay? So usually the 8 is supposed to come before the x. And then the radical, but inside the radical is just the variable. Then 27 times y to the 6th. Okay. Number 9, okay? These are square roots. Oh, multiplication, division. I know exactly how to set it up. Now you're back to having those radicals, okay? So They're both 2's, so we don't need 2 of them, just one of them to the 1/2 power. You can't do much inside, it's just x and then 6 times y. So we got x and then 6 times y. So all these are to the 1, but they all go to the 1/2 power. Not a single one of those is negative, okay? So all you have is the 1/2 powers. Circle them bottoms, okay? Square roots, you know x and y aren't. 6, no, okay? Well, I've got fractions on bottom, so we have to use this line to make the bottom exponents whole. That's called rationalizing the denominator. It says make sure the denominator is rationalized. That means only full exponents down there. So the top I just bring down. Now I give myself some space with these. 6 to the 1/2 times y to the 1/2. Well, you're going to multiply by a second factor of 6. You put a 2. What's 2 minus 1? It's 1. So you got to multiply the top by the same thing. If you're bringing a factor on bottom, you got to bring it on top. Now, that makes a full 6 factor. Then y, 2 minus 1 is 1. That's a full y factor. So that's 6 times y on bottom. You can just fill that out the rest of the way. Now, definitely we have fractions on top. They're all square roots, 2 roots. Those are all 2's. So you make one single 2 root. Put the 6 to the first, and those 2's can be forgotten. 6 to the first is 6. Then your x to the first is x, and your y. Now, any part of that radical can you simplify? Well, let's see. The square root of 6. You're on this list. 6 divided by 4 doesn't work, so no. 6. 6 over 6, okay? A square root is 6 over 6, so you can't simplify the 6 over 6, so nobody should be putting that as 1, okay? Now, that's all multiplication division. See that? There you go. It's right there. Now, the game changes. Now, you're going to see adding and subtracting. Much easier process. See if the radicals are like, or it's not easier, it's just different. See if the radicals are like terms. That means are they the same, they're both 2's, or they have to be the same inside 2. Yeah, they are. So I write 3yx, and since they're the same, I add the outside numbers. 4 plus 10 is 14. Boom. So pretty much if the radicals are like terms, you're done. Okay, like terms means they match. Next one, you got plus. That's going to be a plus negative. These are radical 2's, but they don't match here. So then if they don't match, we simplify the terms individually. So you got 3 square root over 20. 8 square root over 45. Negative 4 square root of 5. Drop your factor of 3. Is 20 a perfect square? If it is, I'm just going to write what it equals, but it's not. So I divide into it. So 20 divided by 16, decimal, 4. 4 and 5, okay? So the square root of 4 turns into 2. So 3 times 2 is 6, square root over 5. Now this other guy, 45 is not a perfect square. You're going to have to divide into it. That is not on the list. If it's 49, I'd write just 8 times 7. Decimal, divide by 9, you get 5. Eight times 3 is 24, square root 5. How about this guy here? It's not a perfect square, but I don't really think it divides by anything, okay? So it will just stay the same. Oh, look at all those radicals. They're now the same. So we put the square root of 5, and we add the 6, the 24, and the negative 4. It's 26. It's 30 Negative 4 takes you to 26. Next problem. I want you to ignore, we're doing the problem. It says FOIL. It's a little hint. You got 5 plus 3 times square root of 27. Okay. On FOIL, I'm not going to put the 2. Okay. I mean, it's a 2. You're going off this list. Then the other side, I got 4 minus. I like plus negative better, and I want a 1 in front of there. So you have adding, but you can't add these. You can't add these. Well, you need to now multiply with the FOIL method and then maybe simplify and see what you can add. So FOIL, you take 5 times 4. 5 times negative 1 square root 3. Then 3 with its square root of 27 times 4. Think of those square roots as just like variables. Then 3 with its square root of 27 times negative 1 with its square root of 3. It's 20. Negative 5 square root 3. 3 times 4 is 12. Square root 27. Negative 3 square root 81. Now write those out. Okay. Now we got rid of the parentheses by multiplying with the FOIL. Any of these match? No, 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 and that doesn't even have a radical. You might as well drop the 20. Now you simplify these individually, okay? So negative 5 square root 3, 12 square root 27, negative 3 square root 81. I don't care if you put the 2's there. If you know it's 2, fine. Drop your negative 5. 3 a perfect square is most certainly not. But if you try to make it into 2, it doesn't work because 3 is too small. So that guy's staying the same. Drop your 12. 27 is not a perfect square, but that's at least big enough to divide. So hopefully we can divide it by something. 27 by 25, no. 27 by 16, no. 27 by 9, yes, 9 and 3. Square root of 9 turns into 3. So it's going to make 36 square root 3. Okay. Negative 3. Guys, don't divide that. The square root of 81's right here. It's equal to 9. That turns into 9. So negative 3 times 9 is negative 27. Okay, now what can you come? Well, we can add the 2 without a radical. 20 plus negative 27 is negative 7. Then the radical I do have, they're the same, and I take negative 5 plus 36. That's 31. Don't add the negative 7 to the 31. Those aren't like terms. That's multiplied by the square root of 3. That one's not. Okay, leave it. Okay, and then this one right here. Make that plus negative, then you need to put a 1. It's adding again. There's square roots, okay? You don't have to multiply anything, okay? But they're not the same. Okay, if you want to put a 1 there, that's fine. Bring it over. Try to get them to be the same. Drop your 1. 8 is not a perfect square, which is why I'm dividing into it. It does divide by 4. 8 divided by 4 is 2. So it's going to be 2 square root 2. Drop your negative 1. 18 is not a perfect square, so if I divide that by 9, I get 2. So square root of 9 is 3. Negative 1 times 3 is negative 3, square root 2. Radicals the same? Yes, they are. 2 plus negative 3 is negative 1. And that concludes the adding part. Now you're solving equations, okay? Solve the equation means find the value of x that makes the equation work. Oh, x is inside of a radical? Circle the radical. Make a line on that side. You got to get rid of these two things. You're going to minus the 3 first. If you have plus or minus, you got to deal with that first. Then if you have a times, you need to divide by 3 in that order. Then you will do your second power, and then you will solve. So minus 3 takes you to 18. Don't divide by the 3 first. It doesn't work that way. Plus or minus has to be gotten rid of first. 18. Divide by your 3. That takes you to 6. Now it's time to get rid of Mr. Square Root. Well, you take it to the second power. That side is now just 2x plus 6. The other side, 6 to the second, is just 6 times 6, 36. Now get x by itself. There's still only one answer. You just use your linear properties. Linear properties means you just get the x by itself. So you minus 6 divide by 2. So 2 times x equals 30. Divide by the 2, and that takes you to 15. Okay? Okay, next problem. Okay, we don't have a radical, but we have x that we have to solve for, and x is inside of parentheses, and we have a power there. So I think I need to use my old trusty friend, the h. So 4h to the 2/3 power equals 36. Remember to make the table so you remember that you're really solving for x, not for h. Okay, well, I got my power here, but first there's the issue of that times 4. You have to divide by 4 before you worry about the power. So you minus 4, that's 9. H to the power of 2/3 equals 9. Now, what do I do about a rational exponent? You flip it, 3 over 2. Now, we have to decide if we need both sides or just one. This means that's the root right there, okay? It's even. So it could be positive or negative. Now the square root of the number 9 is 3, okay, to the 3rd power. That's 27. So on one side you got 27, then you have negative 27. Now you solve for x. So you add 3 and divide by 3. That's 10. Okay, and there's a second answer. Plus 3, that takes you to negative 24. Divide by 3, and you get negative 8. Okay. Okay, number 16, still solving for x. Again, there's that radical again. Anything outside of it? Not this time. There's nothing happening. So we go right to the get rid of the radical. It's a 2, so I use a second power. Now, this side is just x plus 6. But the other side, man, I got to take x plus 4 times x plus 4, otherwise known as the FOIL method. So 1x times 1x. 1x times 4. 4 times 1x. 4 times 4. 1x second, 4x, 4x, 16. Combine those into 8x. They don't cancel because they're both positive. Now, bring that over here. Don't forget you had the 1x plus 6. And now you should see, okay, there's 2 answers. I have x to the second. I've also got x. You got a factor, okay? So equals 0. You got to have one side equal to 0. I'm going to get the side without the x second. So I subtract 1x from 8x. I subtract the 6 from the 16. So there's my 0. 1x second plus 7x plus 10. It's a 3-term factoring problem, GCFT. GCF's 1, okay. 1 times 10 is 10, it's positive, it's a match, okay. got to add to positive 7. So start dividing. 10 divided by 1 is 10. That's negative 11. 10 divided by 2 is 5. That's negative 7. Make them both positive, and it still matches. You're now at positive 7. A equals 1 times x second. So plus 2 plus 5. So I take that 1 divided by 2 on the exponent. It's x. Not doing anything then. So we have x plus 2 times x plus 5, f1, f2 those, okay? X plus 2 equals 0, x plus 5 equals 0. Minus 2, you get negative 2. Minus 5, you get negative 5, okay? Okay, here's the next one. Graph the function, identify the domain and range. This is the last page. 5 times the square root of x plus 9. Now, I'm going to start with just y equals the square root of x. So it's a square root, so we want to do input-output table and only pick perfect squares. So 0, 1, 4, 9. Negatives are not perfect squares. You can't put them in a square root on a graph and get a real output. So stop. Okay. Now we know this. If I put 9 in a square root, it's 3. Square root of 4 is 2. Square root of 1 is 1. 0. Okay. Okay. Now we got to translate this so it matches the actual function. Does anything inside that square root? No, it's not. So you keep the x's the same. Anything outside? Yeah, times 5 of plus 9. So you need to multiply all your y's by 5 and the first, and then you need to add 9. 3 times 5 is 15, plus 9 is 24. 10 plus 9 is 19, 14, and 9. Okay, you got to go by 5s on the y. I know that. X's you can go by 1s. Okay. Here, I'm going to even show me going by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So 9, 24, 9, or no, graph this one first. 0, 9. 0, 9 right there. See, here's x. 1, 2, 3, 4, 5, 6, 7, 8, 9. 114, I go 114. 419, I go 419. I also circle that point, okay? Because you can't go this way, you can only go that way. Then 924. Arrow this way because I could have kept going that way with 16, 25, 36, all that, okay? Now, you need to mark that point 0, 9. So in the domain, you know, the x value is 0, the y value is 9. Now you got to decide the sign to put. Look at all these numbers, 1, 4, 9. I'm pretty sure those are greater than 0. And also it goes to the right, which would mean you're going the greater than direction. Now look at your 9, 14, 19, 24, all bigger than 9. So again, and also the graph's going upward, so greater than or equal. Okay. See, 9, yeah. Next one, last one. Y equals the square root of x minus 2 plus 3. Get the parents set up. Okay. Remember, you can't put negatives in that square root without doing the I, and I don't put I on graphs. 3, 2, 1, 0. Now, inside the radical, you got minus 2. Well, you can either do one of two things. You could set that equal to 0. So that means your x has to be changed to 2. Or you can just look at that, see it's minus 2, and say, okay, inside I know I have to do the opposite of whatever that is to x, so plus 2. Now outside you don't have a times, you just have to add 3. So it's going to be 11, 6, 3, and 2. 6, 5, 4, and 3. Okay, we got to go by 2's on the X. I don't care if you number it, but yeah. Y's, you can just go by 1's. You just have to get to 6. Okay, so stop. You remember, you're stopping there. 2, 3, 2, 3. Label that. 3, 4. So 3, 4. 6, 5. So 6, 5. And then 11, 6. So 11, 6. Now the graph keeps going this way. It does not go past that. So you put X with your 2, Y with your 3. It's not all. All is if it's a cube root and it just goes both ways forever. Okay? This just goes one way forever. So there's a restricted domain range. Gee, look at these numbers. 3, 6, 11. I'm pretty sure those are bigger than 2, so greater than or equal to 2. 4, 5, 6, greater than or equal. Okay, 3. From 3, it's getting higher. Now, also you can see from the X goes to the right. That's greater than on X. On the Y, it goes up. Up is greater than on the Y.